Today we're going to go over 6.2, which is growth and decay notes. So this goes right in with our exponents. So the first thing I want to do is review changing a percent to a decimal and a decimal to a percent. So remember, when we have a decimal, where we need a decimal, we have a percent. Remember, it's kind of like dividing by 100 because it's out of 100%. And when we divide by 100, what you're essentially doing is taking that decimal place that's already there after the 25 and you're moving it over, you're moving it left 2 places. So your decimal for 25% would be 0.25. The same goes for going the opposite direction. Changing 0.67 to a percent is like taking 0.67 and multiplying it by 100. And when we multiply by 100, we're essentially taking that decimal place and moving it to the right 2 places to get 67%. Okay, so we're going to talk about exponential growth and decay. So exponential growth and decay, instead of having a line on the graph, it's going to be moving exponentially. So exponential growth looks like this. Whoops, that's a really ugly line. Exponential growth looks like this. It's going to start low and it's going to grow quickly going up. So now it's like a curve that's growing faster and faster. Exponential decay is the opposite. It's going to start high and it's going to decrease. So that's what your graphs look like. That's what you should be picturing. Now, the difference in the equations between exponential growth and decay are the sign right here between the 1 and the R. If we're growing, we're going to add the rate to the 1. If we're decaying, we're going to subtract the rate to the 1. The rate would be your percent in decimal. Your percent in decimal form is the rate. Okay, so what do all these letters mean? Okay, Y is going to be your output. It's the answer to your equation after however long. Okay, you might be talking about cost. You might be talking about maybe how many rabbits are populating after so many years. Okay, so that's kind of like, I like to think of it as my answer. Okay, the C is your initial value or your starting value. Okay, so I put $500 into the bank. That's my initial value. I started with 15 rabbits. That's my initial value. Okay, the R is your rate. It's in decimal form. And your T is time. Now the time, you have to be very careful. The time can be measured in hours, minutes, days, years. You have to pay attention to what the problem is talking about and make sure you're plugging in the correct time. Okay, the letters all mean the same thing in decay. The only difference, again, is it's subtracting instead of adding. So what does that mean? That means when I have an equation for growth, that number 1 plus R is going to be bigger than 1. So if I have an equation for growth, I would have Y equals some value times 1 point something, right, to the T power. So if this is growth, this number right here is bigger than 1. If it's decay, that number would be smaller than 1. Okay, so that number right here, if it is decay, that number is going to be between, it's not going to be negative, okay, between 0 to 1. Okay, it's going to be something between 0 and 1. Okay, so what does this look like? I'm going to give you 2 graphs on number 1 and 2. I want you to tell me if they're growth or decay. Here's the first one. Here's the second one. All right, so if we look at the first one, what's happening? We're starting high and we're going down. So we are decay. On the second one, what's happening? We're starting low and we're moving up. So this one would be growth. Now look at number 3 and 4. Tell me if those are growth or decay. Okay, so if we're looking at growth or decay, remember we look at what's being either added or subtracted to the 1. So on number 3, it's bigger, 1.3 is bigger than 1, so we would be growth. Now what would be my rate? Let's talk about that for a minute. What would be my rate? Well, what I have highlighted should be 1 plus or minus a number. Okay, so for this one, what are we doing? We're taking 1 plus 0.3. So my growth rate would be that in percentage form. So we can move that decimal over 2 places to get 30%. It's growing at 30%, okay? Or it's growing at a rate of 0.3, okay? Depending on how the question wants that, that's how you do that. Now on number 4, is that growth or decay? Okay, remember we're looking at this guy right here. Okay, if we're looking at that 0.75, that would be smaller than 1. So this one would be decay. Now what would my rate be? My rate, remember it's 1 plus or minus something. So what are we doing on this one to get 0.75? Well, to get 0.75, I'm going to do 1 minus 0.25. And that gives me 0.75. So that right there, that 0.25 would be my rate. Or I could say, I could move that decimal over 2 places and say 25%. Okay, so let's do 2 more examples. All right, so the equation, oh, I have an equation. First thing I'm going to do is I'm going to underline that because I know I'm going to use it. Represents the weight gain of a channel catfish. If T represents the time in days, that's important. I'm going to circle it. Answer the following questions. So is this problem growth or decay? Well, if I look at what's inside those parentheses, I have 1.1. 1.1 is bigger than 1, so we would have growth. What is the rate? Well, remember it would be 1 plus something gives me 1.1, right? What would I add to 1 to get 1.1? I would add 0.1. So my rate is 0.1 or 10%. What was the initial weight of the catfish? If we go back up to our equation, where's the initial weight value? The initial weight is that C. It's the number that's out in front of the parentheses, in front of the rate. So my initial weight of the catfish is right here in front of the parentheses. So 0.3. And I didn't tell you what it's measured in. I think it was measured in grams. Okay, how much does a catfish weigh after 6 weeks? Well, now we're going to actually have to do math, right? So I have my equation. It already filled everything in for me, and it gives me the time. The time is 6 weeks. However, this equation is in days. So what am I going to plug in for T? T equals days. How many days is in 6 weeks? Okay, well, how many days are in 1 week? 7. So if I take 6 times 7, I get 42 days. So that's my time. So I'm going to plug that in for the exponent. Now, how do you plug this in? Okay, you either have a caret or a x to the y on your calculator. Okay, and remember you can use Desmos if you need to, if you don't have one. Okay, so you're looking to plug it in just how it looks, but you're going to do 0.3, open your parentheses or hit times 1.1, and then you're either hitting caret 42 or you're hitting y, x to the y, sorry. Mine's x to the y. Yours might be x to the y or y to the x. Okay, so when you plug that in, what do you get? Make sure you're plugging this in with me and you know how to plug it in and you get the same answer. If you're not getting the same answer, you need to be emailing me and letting me know what happened. So when you plug this in, you get 16.4 grams. That's how much the catfish would weigh after 42 days or 6 weeks. Okay, let's do number 6. So number 6, the equation y equals 18,000 times 0.88 to the t. There's my equation. I know I need to use that at some point, so I'm going to highlight it, circle it, underline it, whatever needs to be done. Represents the value of a car you bought. If t represents the time in years, answer the following questions. So, growth or decay? Well, remember growth or decay, we look at what's in the parentheses. Is it bigger or smaller than 0? I'm sorry, is it bigger than smaller than 1? It would be smaller than 1, so it would be decay. What is the rate? Well, remember this is decay, so we have 1 minus something gives us 0.88. 1 minus what would give us 0.88? Well, I know 1 minus 2 gives me 0.8, right? 1 minus 0.1 would give me 0.9, so 0.12. So my rate is 0.12 or 12%. Okay, if you didn't know how to solve that, you could do 0.88 minus 1 and literally solve this equation. We don't know this, so I'm going to call it x. So if I subtract 1 to the other side, I get 0.12 negative, divide by -1, and that gives you your rate. Okay, what is the initial value of the car? Remember, the initial value is in front of the parentheses. So the initial value of the car is $18,000. How much is the car worth after 15 years? Well, let's see. T represents time in years. So I can plug that 15 in for T. So let's do that. We have y equals 18,000 times 0.88 to the 15. Now let's see what happens. So get your calculators out. Make sure you know how to plug this in. So we have 18,000 times 0.88 raised to the 15 power. And you should get 2,645. Remember, this is money, so 0.53. And that's how much it would be worth after 15 years. So this is exponential growth and decay.